All right, so this week we're going to take a look at polar coordinates. So polar coordinates, it's basically a different way to graph. Okay? As far as the kind of graphing we're going to do, we're just going to graph individual points. We're not really going to be graphing complete pictures like lines or parabolas. We're just going to be graphing single points. And if you've used a graphing calculator or you have one, there is a mode on here for doing things in polar. And I just want to show you, we're not really going to use the graphing calculator, but it is kind of neat, some of the pictures you can get when you draw things in polar. I can draw things that you probably haven't seen before. Like you've seen lines and circles and like parabolas and stuff like that. But you probably on the calculator haven't seen something like that, I'm guessing. So looks kind of like a flower or something. So that's a sketch you could do. We could do something like that. It's more of a spiral. Yeah, kind of simple picture, but again, not one you normally see on the calculator, unless you're using polar. We could do something like this. It's going to look kind of like just a weird, wait a minute, I did that one. Let's try 4 minus. Okay, so some kind of weird kind of design. All kinds of things, even including things that you can do using y equals. Okay, you could graph circles. But to graph a circle, I don't know if you noticed, I just had to type in one number. I just had to type in the number 3, and that automatically drew a circle with a radius of 3. If I wanted to graph a circle doing it the old way, okay, what's called a function, I have to type in a lot more stuff. Okay, so polar is really handy if you want to graph things that are circular. Again, we're not going to do any of those graphs you just saw. We're just going to graph individual points. But the graphs you can do are kind of neat. So this is the kind of graphing we've done before. Okay, you get your x and y axis. X is horizontal, y is vertical. And every coordinate has 2 numbers. It has an x value and a y value. Okay? And depending on if x is positive or negative, that tells you a direction, and same with y. Well, polar is a different way to graph. Okay, so previously we've done rectangular. That's xy. Now we're going to look at polar. So in polar, that's what your graph paper looks like. It's kind of these concentric circles. And you can divide this up. Sometimes they divide this nice and evenly into different regions, like they did on here. But when I draw polar graphs, I usually just sketch it like that, and I just kind of estimate where I need to be. So on your polar graph, instead of the origin, you have what's called the pole, but you could still call it the origin. That's the pole. And you don't have an x-axis anymore. You have what's called the polar axis. And it's numbered going counterclockwise, 0, 90, 180, 270. And to graph a point in polar, you still have 2 numbers. There's a point in polar. But the difference is it's not an x and a y. One of them is a radius, okay, how far you move out from the center of the circle, and then one of them is an angle, what direction you move on the circle. So when you write a polar coordinate, it's written as r, comma, theta. A radius and an angle. Now the radius can be positive or negative, and that'll change how you graph it, and the angle can be positive or negative, and that also has an effect. So, in order to graph a point in polar, the first thing you look at is r. And you move out the number of rings indicated by r. So in the problem that we're going to look at, you would move out to the third ring. Okay. But just like your x coordinate, even though this is not an x value, it's kind of like that in terms of the directions you can move. If your radius is positive, you're going to move from the origin to the right. How many units do you move? Well, whatever r is. Okay, you start at the origin, start at the pole, and you go to the right. What about if your radius is negative? What do you think you would do then?
What does that say? If what?
If r is greater than 0. Positive. But what about if r is less than 0? Which way would you move? Matthias?
To the left.
Yeah, you move to the left. Right, so that's your first step. Either move to the right if it's a positive radius, move to the left if it's a negative radius. Now, after you figure out where to move for the radius, then you have to look at the angle. So after you do step 1, you have 2 directions you can move for your angle. Now, the angle is movement on a circle. When you move on a circle, we don't usually describe that as left, right, up, or down. What are the 2 directions you can move on a circle? Yeah?
Clockwise and counterclockwise?
Clockwise and counterclockwise. And depending on if the angle is positive or negative, it's going to be one of those 2 things. If the angle is greater than 0, or positive, you're going to go counterclockwise. So positive angles, you move in this direction, counterclockwise. If the angles are positive, or I'm sorry, negative, if the angles are negative, less than 0, then you go the other way. Okay, go clockwise. Okay, so counterclockwise for a positive angle, clockwise for a negative angle. And that's all you really need to know to graph points in polar. That's it. Okay, so we'll practice graphing points in polar. We'll try degrees, radians, and then all the different combinations you could have, like a positive radius with a negative angle, negative radius with negative angle. We'll try all of them. But any questions on the directions you move for the angle or for the radius? All right, so let's try. All right, so as I suggested, the first thing I would probably do is convert the point to degrees purely to make the arithmetic easier to do. Okay, if you want to keep it in radians, that's fine. But did anybody try changing to degrees first? You did? What did you get when you changed, Alexis?
30 degrees.
Yeah, so let's change it to 330. And now I'm going to graph that point. So let's see if I can do this. So I'm going to go right 3, and then 30 degrees is 2 sections on my grid. Right. So the first thing they want me to do is keep the radius positive. If I want to land on the third circle, I only have 2 numbers I can pick from. What 2 numbers would I have to use to always land on the third circle? Catherine? Well, think about if you want to land on the third circle, how many units do you have to move out from the origin? 3. And there's 2 ways you can move out 3 units. You could either go sure, Taryn? 3 or negative 3. So for every one of these problems, and even if I made up more, the first number has to always be 3 or negative 3. If it's not, you won't land on the third circle. All right, so we've got the radius of 3, and they wanted it positive. And they basically want me to do this. Go around an extra time. So Josh, how much is that section right there? In blue.
390?
The whole thing would be 390. That would be the answer. But if somebody's not sure how many degrees,
30 degrees.
yeah, that's 30. And then all I did was go around an extra time, and a revolution is 360. Add the 2 together, and that's how you could get 390. Okay, if you weren't sure. So 390, and that satisfies the first one. Any questions on the first one? Okay, second one. They want the radius to be negative. So what number would I have to pick to land on the third circle? And I have to use a negative. How about Shannon?
For the second one?
For the second one, yep.
Negative 3.
Negative 3. All right. I'm going to start by going 3 to the left. So right there. And now they want the angle to be positive. So they want me to go that way. Okay, so you just have to figure out how much that is. Matthias, if I start here and go all the way around to where I stopped, how many degrees is that? 210, yep. So it's halfway, and then it's that section that's 30 more. Okay, so negative 3, 210. And the last one, they want positive radius, but they want a negative angle. So Eli, what does my radius have to be in this one?
2 and 30.
So what's my radius?
So that'd be 30.
Yeah, it's got to be 3 because if it's not 3, you're not on the third circle. And they want it to be positive. But this time they want me to go the other way. So it's basically like taking the long way to get to that point. Okay, so we know it's going to be a negative because the angle is between negative 360 and 0. And how many degrees is it to go over what I just traced? Tom?
300.
Not 300 would be if you stopped
310.
right there.
Which one?
Think about how much is this section?
I thought the section was 10 for a second. So 330.
That's 330. Yep. Because that section in blue is 30. So you're basically going all the way around, except you're stopping 30 degrees short. So it's negative 330. Okay, and there's a few different ways you could write that answer. Okay, any questions on that? Okay, before we move on to the last thing, any questions at all with graphing? Anything, if it's in radians, if it's degrees, positives, negatives, zeros, anything on graphing? Okay. So the last two things in this section are converting between polar and rectangular, okay, each way. Today we're just going to do it one way. We're going to go polar to rectangular. So just to make sure we know what they're giving us, if they give you a point in polar, what are the two letters they're giving you if it's polar? Matthias?
Radius and theta.
Yep, they're going to give you a radius, and they're going to give you a theta. And if they want it in rectangular, what are the two letters you need to figure out? You don't want r and you don't want theta. Yeah?
X and Y.
You want to turn it into an x and y. So that is basically what we're doing. Going to convert an r and a theta into an xy coordinate. Okay, so let's sketch it out and see what happens. Okay, let's pretend that that's a point in polar. How would I draw my radius in that picture? Where do I draw it? From what to what? Josh?
From that point to
Yep.
where the origin.
Yeah, from that point, which go like that, to the origin. That's my radius. And now, can somebody else describe where my angle would be? You could say it's like between this and that. Yeah?
I was going to say the x-axis, but
Between the x-axis and,
the point of the origin.
well, it's got to be between two lines, or two line segments to make an angle. Yep?
Between the radius and the x-axis.
Between the radius and the x-axis. There's your angle, right in there. And now my goal is to figure out how far do I move from the origin, right, and up. So what could I do here? Or what could I kind of turn this picture into that would make it easier to see? Yeah, we're going to make it into a triangle. So we're just going to take a vertical line, and I want to put it right at the end of my radius. Okay, and because it's vertical, it's going to be perpendicular to the x-axis. So this distance that I just highlighted in green, that's the distance you move from the point to the right. And then this distance in red, that's the distance you move up. So our goal is to somehow use this and that to figure out the x and the y. So basically this is just SOHCAHTOA. This is a right triangle trig problem. You'll know r and theta, solve for x, and then separately solve for y. So let's do x first. What position is the side that's x relative to theta? How would we describe that in a right triangle? X is adjacent to theta. So adjacent, and r is across from the 90. So what does that make r? It's the hypotenuse. Okay, anything that's across from the 90, that's always your hypotenuse. And now the question is, what trig function uses adjacent and hypotenuse? Yeah, cosine. So the cosine of my angle equals adjacent, which is x, over hypotenuse, which is r. So what I'm trying to come up with here is a formula for x. So I want x by itself. So how would we get the r on the other side? Multiply by r, and there is your formula to find the x value. You take the cosine of your angle in polar and multiply by the radius. All right, now we need to do the same thing to find the y value. All right, so now I'm still going to use r, still going to use theta, but what's y? What side is that? Relative to theta. Josh?
Opposite.
It's opposite. And we're still using r, which is hypotenuse. What trig function is that? Opposite. That's sine. So the sine of my angle would equal, what would go on the top? What would go on the bottom? Opposite over hypotenuse. You're going to know r, you're going to know theta. We can get y by itself. Same way we did with cosine. Multiply both sides by r. Okay, so there is your formula to find y. And using those two formulas, that's how you convert polar to rectangular. And that's the same thing. So if they give you a point with a radius and a theta, use the following formulas to change it to x and y. Now, for these, I would put your calculator in whatever mode they give you theta. If they give me theta in radians, I'm going to put my calculator in radians. If they give it to me in degrees, I'll use degrees. By changing the mode on the calculator, that's one less step I have to do by hand. Okay. All right, so let's try that. So we've got the point 6 comma pi over 6. And they want me to change it to rectangular. So Ben, first of all, is this, are they giving me an angle in radians or degrees? Radians. So what I'm going to do if my calculator is not in radians, I'm going to change to radians right now. Just so when I start typing stuff in, I don't forget. All right, so I'm already in radians, so we're good. All right. We're going to change to radians because this is in radians. You would know if it's in degrees because it would look more like that. All right, so x is r cosine theta. So Dylan, if I fill in r and theta in my problem into that formula, what will my equation say for x?
Probably put in my calculator.
Just filling it in, and we'll put it in the calculator together.
For x would be 6.
Yep.
Cosine 5 6.
5 or 6. Okay, we'll come back and we'll figure that out in a second.
Y.
And yeah, do you want to do y?
Sure.
Okay. Yep.
Be 6 sine 5 6.
6 sine pi over 6. Okay, let's type both of those in. I already know I'm in radians, so I should be all set. As long as my calculator comes up. If not, then there we go. All right, back to what we're doing. So 6 cosine pi over 6. Okay, and then I'll round that off to about 5.2. it's about 5.2. And y, okay, same thing, we're just going to type in sine. So 6 sine pi over 6 is 3. Okay, so you've got the x and the y, just write them as a coordinate. X, comma, y. There's your coordinate. Now, what I'm going to do is I'm going to take the point that we had in polar, which was 6 comma, what's pi over 6 in degrees? We did that earlier. 30. I'm going to graph 6 comma 30. Right 6, 30 degrees. And what I'm going to do is I'm going to change the background. I'm going to leave the point exactly where it is, but I'm going to put a rectangular background in place of that one. And if I did this correctly, it should look like this point is a little more than 5 units to the right and exactly 3 units up. Okay, so let's put a rectangular grid that's exactly the same scale in place of that one and see what happens. Okay, so does that point look like it's at about 5.2 comma 3? Yeah. Right, so there it is in rectangular, and there's the same thing in polar. Okay, and this is a polar grid. On this one, I think they divide the circles into smaller circles, so you can really make a lot of circles if you want, but I've been using the biggest graph. Okay, so any questions on that one? All right, so on the test, the way you might see something like this written would be like this. That's how they would write the answer on the test. 3 square root 3 comma 3. Now earlier, Alexis mentioned that chart, okay, that has all those numbers in it. People know what chart she's talking about? It's that chart's got all the numbers. And the way I did this is basically in my head, I went to the sine column, I went to pi over 6, and I looked at the number that was in that column, okay, in my head. And I saw root 3 over 2. And then I said, okay, I'm going to multiply that by 6. And then 2 went into 6 3 times. Now, if you don't remember that chart, you're not going to be able to do that. So what's another way, if you saw this answer in black on the test, that you could match it up with the one in blue? I mean, the 3's match. But how could you see if 3 square root 3 matches? What would you have to do? Josh?
Solve
And how would you solve that? What would you do?
it. Take the square root of 30.
Yeah, just get the decimal for that. So if you don't remember that chart, the only way to match the answer up with that decimal is to take the square root of 3. Thank you. And multiply by 3. And there you go. 5.2. Same decimal. All right? So 2 ways to do it. 1, you'd have to have that chart memorized, which I'm guessing is a little rusty at this point. Or 2, take what they write, change it to a decimal, and you'll see it comes out the same. Okay. But that will come up on the test. Okay. Questions on that? All right, and the last one. I think it's the last one. Yeah. Why don't you try that one? Okay. See if you can get the equation set up. And this one, same type of thing would happen. There would be a square root on the answer for the test, but I'm just rounded to decimal. Okay? I'm just rounded to 2 decimals. All right, so let's finish up. All right, so my x1. What's the formula just for the x? You don't even have to give me the answer, just the formula.
Do negative 4 cosine 120 times.
Yep. Negative 4 cosine 120. And can somebody else give me the y? Matthias?
Negative 4 sine 120.
4 sine 120. Now, if I'm going to do this on my calculator, what do I have to be very careful about, especially since I just did the last problem?
Switching back to degrees.
I have to switch my mode back to degrees because I'm still in radians. But I'm just going to see, did anybody get what these come out to? Yep, Emily?
2
The first one is 2,
and negative 3.46.
negative 3.46. Okay, so just write it as a coordinate. 2, comma, negative 3.46. Okay, most of the mistakes, if you didn't get that, some people on their calculator, they have to type it in backwards, which is awful. So if you have to type it in backwards, you can use one of my calculators if you want, because you type it in exactly the way you write it on paper. Type it in backwards is confusing. Or the other mistake I see is you're in degrees instead of radians, and you need to switch it. Okay, something like that. Okay, any questions on that one? All right, so with the time you have left, just about 15 minutes. I'm going to give you some time to start the homework. So it's on page 308. And it's all evens, 12 to 26, 40 to 46. On 12 to 20 through 26, you might want to draw your own grid because those are graphing. And then 40 to 46, you'll need a calculator.